Hi there. A lot of tutorials that talk about AI agents introduce many libraries. These libraries bring with it a ton of boilerplate code and then too many concepts upfront. In this mix, what an AI agent truly is and truly does gets lost. So I thought, let me remove this boilerplate code. Let me remove all the libraries that are not necessary for the first run of AI agent and arrive at the most smallest diminutive AI agent possible. This helps us understand what an AI agent truly is and truly does. And all of this in just 50 lines of code. So let's dive in. The writing of the AI agent, I have split that into 5 different steps. We will go through each step and incrementally build the AI agent. And at the end of every step, we have something to test out. The first step is all about writing a basic post API. We want the user to send a message to us, and I want to expose an endpoint called /chat. And in this step, I will just return that back to the user, just mirror what the user gave. This has nothing to do with AI, but then this gives a very good entry point for us to test out our AI agent. For this, we need Python. We'll write code in Python, and Flask for bringing up the API, and Postman for testing. I'll bring up my IDE from here, which is Visual Studio. This is my IDE. Let us check the version of Python I have. I have 3.8.8. The version of Python should not matter for the exercise we are doing. Let us create our first and only file that we need. Our first lines of code. From Flask, I import Flask request and JSONify, which we will use later. I need to create an app. And then I say app.run. This is the way we bring up any Flask server. But then I don't have an endpoint here, and the endpoint is /chat. Let us put the code in for the endpoint. A very standard post request for Flask. App.root is /chat and the method is post. Whatever the user sends, I'm just returning it back. This is what we wanted to do in step 1. Now let us take it for a test drive. Let me bring up the Python server. Let's come up on localhost 5000 port number. This is my Postman interface. I'll hit it with the JSON request. Yeah, so it's working. I just sent a message to my server. The message has the key called message and total of 6 and 4, and the server responded me back with the same message that I sent. Just to see it's really doing its job, total of 6 and 7, and then it just returns that back to us. Now we have a basic post API, and this completes our step 1. Having successfully completed step 1, let us jump to step 2. We will push a little bit here. Whatever the user sent as a message, I now want to send this to an LLM and then get the response back from the LLM and then give it back to the user. But then we don't have an LLM yet. So how do we get that LLM? There are many different ways, but for this tutorial, we will use an LLM that is provided by any inference provider. Before jumping into coding of this, I want to slightly digress a bit and talk about how do I get that LLM. The LLMs that you have heard of, Mistral, Llama, Quan, Gemma, all of these are called as open weight models. That means that you can download the LLM and run it on your own server. There are many of these companies which have infrastructure on the cloud, GPUs and CPUs. They have taken these open weight models and then put them on these machines and exposed an API layer for us to use. So these companies are called as inference providers. Grok, Together AI, Deep Infra, and many such companies for that matter. Here it is GROQ, not GROK. GROK is from X, formerly Twitter, but GROQ is an inference provider. We will use GROQ for the purposes of this tutorial. When these inference providers expose the API layer, they expose it using OpenAI standards. This has become the industry's de facto standard. I can switch between inference providers, I can switch between LLM models, and my code need not change. But then take this with a pinch of salt, because this is not an official standard and because each LLM can expose many other capabilities. There might be some changes in the request and response when you move from model to model or an inference provider to another inference provider. But then this is just a very small hurdle to cross. Now, how do I get access to this? All of these inference providers have this standard way. You go there, create an account, get an API key. The API key which would look something like this. And then they will expose primarily 3 different ways of accessing it. 1, use their own SDK. 2, use OpenAI's SDK. And 3, we can make regular HTTP calls. So for the purposes of this exercise that we are doing, as I did not want to bring in any other library, we will just make use of regular HTTP calls. So to complete this step successfully, we need Grok API keys, which I already have. We need a request library to make HTTP calls from Python. Now let us jump to the coding part of it. Install requests, import requests, define the headers on the message. The header has the API key, and then the message says the role is user, and then the content is whatever the user sent us. And now the actual call to the LLM through requests. The API says chat/completion, the headers that I have just defined here. The model that I want to use is 70B Versatile Llama. For the purposes of this tutorial, any other model that you choose should also work fine, because we are just doing the hello world of the agents. And now, instead of returning body, I want to return whatever the response from LLM is. That's our code. Now let us test this out. The same drill, I'll bring up my server, go to Postman, and now check the response. The LLM responded back to us, and then it says 6 plus 4 is equal to 10, and then it picked up the role of an assistant. This response also has many other details about the tokens that you have consumed, and then it has a standard response format of choices, and then an array, and then a response within it, and then the message, and then the content. It is the content that we should actually be interested in if we are returning it back to the end user. But then, because we want to know what the LLM truly gave in its full sense, I'm just returning back the whole message. So this completes what we wanted to do in step 2. We contacted Grok, hired an LLM there. We took the inferred response and sent the inferred response back to the user. This is not an AI agent. This is just an inference that we are trying to make. Now let us move on to step 3. The step 3 is about tool awareness. In step 2, who did our core business function, that is addition? It was the LLM that did the activity. Extrapolate this use case, and what if you had a complex business solution? 1, you may not trust the LLM to do it correctly. 2, LLM might not even know how to do it. So we will have to write the business functions that we want, but once I write it, I will have to let the LLM know that I have a business function and I will execute it. All you need to do is just pass the message and then let me know what tool and what parameters I have to use. So that's our next implementation. We will convert our business function of addition as a function and then let the LLM know that we have a tool called addition that exists with us. And now when we do this, let us see what the LLM gets back, and the same thing we will send it back to the user. We have all the moving parts necessary for this step and we don't need anything else. Now let me write our complex business solution. That's it. Now I need to let Grok know that I have a tool like this. And this is a standard tool definition which says it's a function. The name of the tool is add. This is the description. The description is important. And then it takes 2 properties, A and B, and both of them are required. This gives a structured input to the LLM. Now I need to pass this to the LLM. I say this is my tool definition. I have only one tool with me, and then the tool choice auto. So with this, let us try to see how the response changes. The drill is same. Bring up my server. Go to request. This was my previous execution. Now hit the server back. Now see, the response changed. The LLM did not do the actual activity of adding 6 and 4. But instead, because I sent a tool along, it said that, hey, there is a tool call that you need to make. The function is add and the parameters are 6 and 4, and then now you go and execute this function. We have now successfully completed step 3. In step 3, we made the system tool aware. Whatever was the inferred tool from the LLM, we will execute the tool with the params that were decided, and then we will send the response back to the user. The details about the tool were in choices 0 message. I'll pick that, extract the arguments from there, and then execute our tool, pass the same arguments that LLM gave us, and return back that response to the end user. Now I don't need this. Same drill. Start the server, go to Postman, send this. Awesome. We sent the total of 6 and 4. It passed us parameters. We executed the tool, and then the result is 10. Let me change this. 6 and 6. The result is 12. Good. Now see, even though I sent the request in words, it was still able to extract the parameters, and then we were able to execute our tool. Imagine without an LLM, how would you have done this correctly? We have finished step 4, but then even with executing a tool, we have not really created an AI agent. Step 5 is the most important step, which truly defines what an AI agent is. The step 5, the true AI agent step. Until now, we took a message from the user, wrote a tool, injected the definition of tool to the message, sent it to our LLM on Grok. It sent back the inferred tool, we executed, we got the response, and this response we have just sent it to the user. Now in this flow, we need to implement something very important for us to call this as an agent. I will explain this step and then go to the technicalities of it. So whatever answer we got, you saw that it was a clinical answer which just said 10. So we have acted upon it, but then we also need one more step of observation. We will come in here, execute our tool, get the response, send the response back to the LLM, and get the final answer from the LLM, and then return that answer back to the user. So this loop is the true AI agent loop, because if you think about it, what is this actually doing? First, it thought about it, sent back the parameters to us, and then there was an action, and then after the action we send it back to the LLM, and it observes what has happened, and then it sends the final answer back. We can continue to do this over and over again in a loop, because if we had the message as what is the sum of 6 and 4 and then add that to 20, now we have to do it 2 times. And what if it is a complex business use case, like get all the users who have registered in the past 3 days, that's a database call, send a mail to each one of them, that's another action. So there can be multiple tools that we can chain together. So this whole thing is called as the React loop. Not to confuse with the React library, this is reasoning, act is action. If this loop is called as React action, what it is actually doing is thought, action and observation, TAO as it's briefly called. We have all the things necessary to execute this step. We know how to hit the LLM, we know how to get the response back, we know how to send the response back to the user. But then for us to truly complete this step, there is one more little understanding about LLM that we need to get. Let us finish this and then go to the coding part of it. If you were to hit the LLM as independent API calls, this is what happens. Let us look at the left hand side of it. You first say, what is the weather today in Bangalore? The LLM replies back, it's sunny. Whether it can do it or not is a second question. It replies back saying it's sunny. Now, you have a follow-up message and then you say, what about Texas? Now LLM says, what do you want to know about Texas? As humans, we link these two things together. Now I just asked it about weather in Bangalore. So now when I say, what about Texas? Am I not asking about the weather in Texas? That's what we understand. But then for an LLM, message 1 is a separate call, exclusive. Message 2 is another call. It has already forgotten about message 1. It's a new conversation that you're having with LLM. We need a way in which we can link all of these conversations together. We say, what is the weather today in Bangalore? It replies back, the weather is sunny. And now, when I have to send a second message, I need to take my first message, take the response, and then add my second message and send whole of it as a message to the LLM. Now, because LLM has a context in which I am talking, because it knows that first he asked about the weather in Bangalore and then I replied back, and then he is asking about Texas. So he is referring to the weather in Texas, and then it can respond back correctly. So this chaining of messages or building this whole context to the LLM is necessary for us when we call the LLM the second time. Let us do this by code. Pretty standard. We'll just append the messages and then send it to LLM. Collect the response in a variable. To the messages that we already have, let us append the response from the LLM as the second message. Now for the message that we need to send, in the content, I am attaching the response that we have. Now this messages object has three messages. The first message, the second is the response, third message is the execution of the tool, and we are tying all of this together with a call ID. Once I have prepared this messages object, now I need to hit grok again to get a response from the LLM. The same kind of call we did before. Ideally, you would have all of this in a loop and then you have your functions and stuff like that. But for us, it is sequential, good enough for a hello world. Now let us test this out. The same drill. Bring up the server. Go to Postman. Previously, it sent just 12. Now with the React loop, let us see how the response goes out. Cool. Now in the final execution, I sent 12 to the LLM. The LLM framed a good response for the end user. The total of 6 and 6 is 12, and then sent it back. Another test. 4 and 16. 4 and 16 is 20. Awesome. Congratulations. At the end of step 5, you have now implemented your first true React AI agent. Now for the recap. We started with a basic post API. Added inference to it by calling an LLM on grok, made this system tool aware, and now we inferred the tool and then the param. We executed the tool in step 4, and in step 5 we implemented the React loop, thought, action and observation. Now that you have the smallest, most basic AI agent, you can now go about adding layers and layers on the top of it to make it truly production. As they say, how do you eat an elephant? Bite by bite. And I hope the first bite we took, you liked it. To the KnowDoAI channel, I'm excited to bring more and more fundamental, no fluff, practical AI content to you. If you like what you are seeing, please like, share and subscribe as they say, and then interact with me through the comments so that I can bring the content that is most relevant to you. Thank you for your time.